Okay, so we have a video here. It's about how there's some anti-gravity or UFO technology that is being revealed by this person, and it's above top secret security clearance, and he's going to talk about how it works. So let's listen.
But this is showing the same effect Einstein's equations predicted about the warping of the time-space fabric. That's the best way they could describe it. But you are seeing here, you're actually seeing it. Instead of an equation, you're seeing it. See what I'm saying? All right. Now, I'll pause on this for about 10 seconds.
Okay, now let's note what he said. He said instead of an equation, you're seeing the effect here. So what he's done there is given us something to think about before he's presented us the equations. He's given our mind this anomaly of understanding of the physical world. We see this thing that's happened, and it's strange, and we don't know exactly what's happening. So now he's going to explain it with some equations.
Okay, this equation here is the one I used to generate what you're going to see in a minute. There's a yellow, a green, and a red equation, and these are the constants I plugged into those to show you how the divergent wave and the convergent wave add together to give you the yellow thing.
Okay, so let's talk about his language here. He has specifically noted that Einstein's equations predicted this behavior, and that he used these equations and he put those constants in the equations that he used. So I'm willing to believe that, because you see B right here is defined, and what you should see is something along the lines of this. This is correct. This says that B is greater than or equal to 300 but less than 480, giving B a range. But what we see here is B is less than 300, but it is also less than 486. Thus, B being less than or equal to 300 and less than 480 is, oh, this is Python. 300 is equal to or less than B, and is less than or equal to 480. This is the same thing as saying B is less than 300. Less than or equal to 300, excuse me. Because anything that's less than 480 must also be less than 300, but greater than 300. So this is the same thing as this logically. Now, let's talk about how he's presented it. He said that he made up these constants and put them into these equations. I'm willing to believe that, because this is just blatantly incorrect. Another thing, M. Let's talk about M. Science is pretty complicated. Science is hard to understand, and scientists and mathematicians do their best to simplify equations in such a way that they're easy to use. Some things are very difficult to simplify. Mathematicians everywhere go through proofs and years of college and training and hard work just to simplify equations and to prove that things work. But this person, who claims to have played a part in inventing anti-gravity, which would be cutting edge and just the most difficult thing ever, has failed to identify that M is a constant and a constant cubed is still a constant, thus nullifying the purpose of constants. M cubed is a constant. M is a constant. Why are we cubing it? This should be a constant. There's no reason for M to be cubed here. So let's do some further psychological analysis here. Now, let's replay what he said
It
here.
is so flat. One way, bits go to this. Don't have them. This is little here. Okay. This equation here is the one I used to generate what you're going to see in a minute.
This equation right here is what I used to generate what you're going to see here in a minute.
There's a yellow, a green, and a red equation, and these are the constants I plugged into those.
These are the constants that I plugged into those. I'm assuming he's using a laser pointer to show what we can't see here. He plugged into those. Constants that I plugged into those. Gee, it sure does sound like a high schooler is describing this math. I think that I've got enough evidence here already to show that when he made this, it must have been in 5 minutes if he has any credibility at all, because a lot of it is wrong. Just on the premise, without even looking at what it produces. Now, later on I will show you that it does have some validity because of the type of curve that it produces, but that type of curve that it produces is found on Wikipedia. There's nothing special about it. It's been known since the 1600s when sine and cosine, maybe even earlier when sine and cosine were invented. I'm not sure on the history of mathematics there, but let's continue listening.
To show you how the divergent wave and the convergent wave add together to give you the yellow thing.
Divergent and convergent wave. Okay, now he's talking about this guy right here and this guy. What he referred to as the yellow thing and the green thing, I think, are his colors. I can't see because it's gray. Anyway, so this is, as he said, a convergent wave and a divergent wave. Now, in my understanding of what a divergent wave and a convergent wave are, is, now, I said it wrong because I just said it wrong for quoting him, but you can't have one divergent wave. You have to have two waves that are diverging, and even then you're using the wrong word. You have waves that can constructively interfere or destructively interfere. That's how waves work. They're in different phases and different amplitudes, and when they line up just right where the top of one amplitude is on top of another amplitude that's also high, it constructively interferes, i.e. the wave gets bigger. This is known again since the 1700s, or whenever it was invented, whenever it was discovered, really. Divergent and convergent waves are not anything that I've ever heard of. In fact, let's go to Wikipedia. Divergent wave. I don't see anything. Usually when you type in something that's known in mathematics, it shows up right on top. Let's talk about divergence. In calculus, we learn that divergence is something that we describe a function that does not have a center, if you will. Something that's divergent, if you take the limit, it goes straight to infinity. Like if I told you I need you to count sheep until you run out of sheep that you can imagine, you're going to count sheep until you die. You'll never reach the end of the number of sheep that you can imagine. However, if I tell you to count all the sand on a beach, and I give you a box that contains a beach, it's a rather large box. It's a beach contained within a box, and I tell you to count each sand particle. Eventually, you'll run out of sand to count. That would be a divergent versus convergent analogy there. The sheep that you're counting, there's an infinite number of sheep. So me telling you to count the sheep is a divergent action versus a convergent action is something that converges on one result. There is one converging thing. There is a right answer and it converges to this spot. Now, I searched a little further because maybe there was something that I didn't understand. So here we have convergence in a wave. So there's a thing called Stokes wave, and I don't know all of the theory behind it, but it's a type of wave and a type of analysis on a wave. But when you talk about the convergence on this wave, again, it goes back into calculus. You can read this if you want, but it's down to the same thing where it converges on one spot. There's this peak here, and I think that's what it's talking about, is this little peak here, and it converges to that peak, and then it goes on its merry way. So it's this calculus 2 thing, and you can look at it, just Google convergence versus divergence calculus, and you'll kind of get the idea of that. But we're not talking about calculus 2, we're talking about waves. Waves don't converge or diverge, they interfere constructively or destructively. That's how that works. That's what that's called. So unless there's a branch of math that I missed when I got to wave equations and such in my modern physics class, I don't know what he's talking about, and I can't find it on the internet either. So it's not something that's mathematically defined, and convergence and divergence is something that's been mathematically defined since the 1700s. Part 2.